Good morning. Today I'm going to discuss how to construct circuit diagram from no load and block rotor test. So from no load and test data and the block rotor test data we have to use for construction of the circle diagram. So here I am showing the circle diagram. So it's a y-axis and x-axis. In the y-axis we have to take voltage as a reference. Voltage measure as a reference. With respect to voltage, we have to mention the no load power factor angle and block rotation power factor angle, and then we have to calculate the power factor angle. So this is the construction of circle diagram. Here all the procedure steps I have given here. Once you go through those steps, so that you can easily understand how to draw the circle diagram. So these steps, once you go through that one, so total I have given 9 steps. 9 steps, carefully read it and copy down. And from this circle diagram, we can also find out the performance parameters. So using the graph, we can calculate all these values. Input power to rotor efficiency, all the calculations we can do using the circle diagram. So now I will explain how to draw the circle diagram. So now see here, first with the no load test data, I'm measuring the no load power factor angle. So from the no load power factor, I have to take no load power factor angle. With respect to V, I am mentioning this is your no load power factor angle. So with the help of no load current, it will use some point on this line. So it is a O dash. So this you will get a new point O dash. So after getting the new point O dash, you have to extend this line. You have to extend this line. So with that is parallel to this horizontal axis. So O dash B, we have to draw a line. That line should be parallel to the x-axis. Now after drawing this line and draw one more angle, that is a block rotor test angle or pi SC, short circuit test angle pi SC. So with respect to V, we have to mention this is your pi SC. And again draw, extend that line, and that line you mention the short circuit current during block rotor test. So that current value gives a point A. So from A you have to join O dash. From A you have to join O dash. So then you will get the line. That line is called output line. From O dash A you have to join a line. That line is output line. Then you have to make perpendicular bisector of O dash A line. So if you make perpendicular bisector, so like this I am preparing more than half distance I am taking to this output line. Like this arcs I am making, so that I am joining these two arcs. Then I am getting a point on the O dash B line that cuts the O dash B line at point C. So this is your center. Like this we have to find out the center for the given problem. So from O dash C as a radius, O dash C as a radius, draw semicircle. So like this you can draw the semicircle for the given problem. Next, from the given data, next you have to find out the output power. So the output power WSN you have to calculate. So that WSN power using the formula you have to calculate, and then that output power convert to using power scale. You have to get some value for that power scale given in the formula. You can see that. So WS. So using this formula, you have to measure the WSN power. Then that you have to convert into power scale. So that will be like this. So the output power you have to draw on this line. So you have to extend the output power like A dash. So then this output line O dash A, you have to draw a parallel line. So that P A dash is your parallel line to O dash A. You have to draw PA parallel to this output line. This line will touch the semicircular point P. So from that point P, you have to extend this line onto the x-axis. And same here also, from point A, you have to extend that line to the x-axis. So it cuts b-axis at F, x-axis at D. So these are the A, F, D. So this A to F will use your total losses, total copper losses, and F to D is your fixed loss. So this is a total copper losses and this is fixed loss. After drawing the line, this parallel output line, then we are extending this line here. So we have got a Q point, it is on the output line, R point and S point, T point. Now how to draw this dark line? Dark line, if rotor copper losses and stator copper loss equal, then you have to measure the distance from A to E, A to F, that divided by 2. So then you will get the rotor copper loss and stator copper loss. Means from whatever the distance from A to F is there, that distance, if both losses are equal, then we can make it is half of the losses for copper loss and half for stator copper loss. So from that point, from point O dash to E, you have to draw the line. That is your torque line. And then from point P to O, you have to draw a line. So this will use your full load current, IFL. And you can measure this angle. This is your new power factor angle. So this you can measure using protector. So this will use the power factor angle. This the length will give you the current, load current. With the if you multiply with the current scale, you will get the current. Or else this will we can also be calculated like from the triangle OPT. From the triangle OPT, you can calculate the power factor also using the formula cos pi equals to PT by OP. So from the triangle OPT, if you apply cos pi, PT by OP, then also it will use the power factor. Next, how to find out maximum power, maximum torque. So maximum power is the you have to draw a perpendicular to the from the center. You have to draw a particular perpendicular to the center to the output line. So this is your output line. So you have to draw a perpendicular line. So this is perpendicular line to the center point. Then that line, if you extend, it will cut the circle at point M. So from that point M to draw downwards vertically onto the output line. So then this length mn will give you the maximum power output. And then how to get maximum torque means similarly torque line. This is your torque line. From the torque line you have to draw a perpendicular bisector. This is your perpendicular bisector to the torque line. Then extend this line, it will touches the axis at point J. From J perpendicularly draw downwards that up to torque line that meets at point K. The length JK will give you the torque, maximum torque in synchronous quartz. If you get to want to know the max total input power, so from the C directly draw a line to the top of this one. So this L dash will give you total input power. So these are the different uh, parameters we can find out using the circle diagram. So go through the procedure so that you can easily solve the problems. Thank you.